All right, tonight we're looking at applying the systems that we've been practicing. All right, let's look at this word problem. These will look familiar. I have two trains and they're running on parallel tracks. The first train leaves the city 1/2 hour before the second train. The first train travels at 55 miles an hour. The second train travels at 65 miles an hour. How long does it take for my second train to pass my first train? Okay, so I've got some numbers going on. I have two different variables. I have my train, A, and it's going this way. And I've got my train B, and it's going this way, parallel tracks. First train leaves 1/2 hour before the second train. So this guy, if I make my blue my t, the amount of time that it takes, then it's going to take this one t plus half. It's been 1/2 hour before. The other way I could write this is I could let this be my base t, and this becomes t minus 1/2. Either way you want to write it, doesn't matter. Now remember that distance equals rate times time. And so I'm going to want to make a chart for my distance, my rate, and my time. And I have my pink train and I have my blue train. And I know the rate is the speed. So 65 miles an hour is how fast my blue train is going. Blue down here, pink up here. So my blue train is going 65 miles an hour. My pink train is going at 55 miles per hour. Oops, and I just put those in time instead of rate. All right, this is what your chart should look like. Now, I can use what I know about linear systems to create these equations. Think about these as a system. If I think of my pink train as d equals rate times time, my distance equals 55 times t plus 1/2. And my blue distance equals 65 times t. And with what I know about systems of equations, I can treat this like a y and an x, if I remember that y is my independent variable. So knowing that these are both equal to d, I can set them equal to each other. So I can get 65t equals 55 times t plus 1/2. And I can see what my t's equal, and then I can plug it back in to get distance. The other thing you can do is you can actually end up graphing these. Go ahead and put this into your calculator. Put both of these equations, this one into y1, this one into y2, and I want you to graph them. And when you graph them, I want you to go to calculate, and I want you to calculate the intersection point. You're going to have to eyeball it. It's going to ask for your left bound, and you want to go, let's say they intersect roughly here. You're going to want to move your cursor down to about this area to give it a left boundary. And then you're going to want to, it's going to ask for right bound, and you move your cursor up and you press your cross arrow until you get a cursor on this side of your intersection. And then you hit enter for OK, and it will give you the point of intersection. And the point of intersection is going to be a coordinate pair. Now, it's going to give you an x and a y. Now, when it gives you an x and a y, let's look back at our equation here. What is my x? Well, my dependent variable is time. I'm sorry, independent is time, and my dependent is my d. So my x variable is going to tell me the amount of time it took to go that distance. Okay, this is going to tell me how long until they meet. So just after that will give me the time to pass. And now hopefully you're seeing how you can apply what we've learned to make it easier to solve certain problems like we've done before. All right, I want you to look at this problem next, and I want you to write an equation or a system of equations using this. You might find it helpful to do your chart, and you might find it helpful to draw a picture. But ultimately, I want you to get a system of equations, and I want you to plug the first one into y1 and the second into y2, and I want you to find their point of intersection and tell me if you can identify the distance. You might have to solve for y. See if you can do this one on your own using the video from before. Check your work. Hopefully you got 275 miles. If not, go back and check this again. See if you remembered D equals rate times time. Your rates were 50 and 55. And if it takes them 30 minutes less, maybe come up here and see, did I do this right? On which one was faster, trip 1 or trip 2? Well, trip 2 was faster, so if this is my t, this is going to be my t minus 30. See if you can figure this out now if you missed the former part. All right, let's look at this one. I've got some interesting vocabulary going on here. A metal worker has some ingots of metal alloy. What? Ingots. Okay. Ingots are these guys down here. An ingot is basically like metal, think bricks of various materials. So I have some ingots of a metal alloy. It just means a certain percentage of metal. So I have some ingots. I have these and I've got these. These ingots are 20% copper. I'm going to write that on these. Some of these are 20% copper and others are 60% copper. Let's say these over here. Some have more copper than the other. How many kilograms of each type of ingot? So here I've got two different types of ingot going on. I have my 20% copper over here, and I've got my 60% copper over here. This one has more copper in it, this one has less. Okay, so how many kilograms of each type should the metal worker combine? So I'm going to end up wanting to mix them up to create one that has, to create one that's 80 kilograms of a 52% copper alloy. So ultimately, these 20% to these 60%, and I want to add a certain amount so that what I end up with is these guys over here that have 52% of copper in them. So I'm going to need to write a system of equations to represent this. Let's let this guy be letter A and this guy be letter B. And then ultimately I'm trying to get my C. So I'm going to have some amount of my 20% copper, and I'm going to add to that some amount of my 60% copper. And together that's going to give me 80 kilograms. I want to know how much to get 80 of this guy. C equals 80 kilograms. Okay, now let's think about this in terms of the percentages. So A is 20% or 0.2 copper, and I want to add to it some amount of my 0.6 copper, and that is going to give me a 52% copper. Okay, knowing this now, and my C is 80, so it's 52% of 80. So now looking at this system, is this going to be an easy one to graph? Not really. I'd end up having to solve them both for a variable. So let's think about some of our other methods. I could use substitution. This is A plus B. I could really easily shift that around. So A equals 80 minus B, and then plug that in down here for A. That's one method. The other method that I have is to do elimination and to multiply something by something that'll give me either 0.2 or 0.6. It's not too hard. I could multiply my top one by negative 0.2, and I'll end up with negative 0.2a plus negative 0.2b equals 80 times negative 0.2. And to that I can add 2a and 0.6b, and that equals 0.52 times 80, whatever that is. And then I can end up eliminating, not that one, eliminating these terms, and I get a 0.4b equals whatever this is over here. And then I solve by dividing both sides by 0.4, and I get my B. And then I plug that back into this equation, and I solve it for A. The other way I can do this is to go back and say, well, if A plus B equals 80, then A equals 80 minus B. And I can come up here and say, if that's true, then 0.2 times 80 minus B plus 0.6B equals 0.52 times 80. Solve this out. And you're going to end up with 160 minus 1.4B. Anyways, it's a lot more work. I honestly think this way is going to be way faster for you. So notice when I have both equations in standard form, elimination's usually pretty easy. If I have one equation in slope-intercept and the other in standard form, then substitution is best. And if they're both in point-slope or point-intercept form, then it's really easy to just simply solve them by graphing. And now you know how to figure out how to do these with word problems. Let's look at another example. All right, let's look at this one. It's very similar. Suppose you combine ingots of 25% copper alloy and 50% copper to create 40 kilograms of a 45% copper alloy. How many kilograms of each, as in each of these down here, do you need? This is a situation just like above, where you're combining ingots to create something else. Using the video from the last few minutes, I'd like you to do this one on your own and show your work. All right, if I'm looking at this, I want to point out something. A break-even point. I'm sure you've heard this at some point. The break-even point is the point at which something equals another. Let's look down here. Here I have expenses or dollars on my y-axis and the number of items I sold. At what point do the number of items I sold with my income being in blue? So down here, I'm not making any money. I'm selling and I'm making items, right? But I'm not actually making any money. So at some point, I want it to break even. I want my income to equal my expenses. So everything over here, this direction of my break-even point, I'm losing money. I've got negative money. I'm spending more than I'm bringing in. Over here on this side of my break-even point, everything over here is profit. Okay, so I want, if I'm asking you to find the break-even point, it's a point at which my two lines intersect, and it means everything after that is profit. Okay, let's look at a situation where you're asked to find it. Suppose a model airplane club publishes a newspaper. Expenses are $90 cents for printing and mailing each copy, plus $600 total for research and writing. The price of each newspaper is $150 per copy. How many copies of the paper must the club sell to break even? So at some point, I'm losing money selling my newspapers. At some point, I start making a profit. How do I figure that out? Well, I need to come up with a system of equations to solve it. So how can I write a system of equations here? I need one to represent expenses, my pink, and I need another one to represent my profits. Okay, I'm selling it for $1.50 per copy. Let's look at this. I've got 90 cents and I've got 600, and this is 90 cents for printing and mailing each copy. Each is always multiplication. So that's per paper, plus is always add 600 total for research and writing. So this equals my expenses. Down here, I am going to find that my price of my newspaper is $1.50 per copy, or per each of my papers. How many copies of the paper must I sell to break even? Okay, so I have a system of equations here. My pink represents my expenses, and my blue represents the money coming in. So fortunately, these are both in y equals mx plus b. Anytime I have two situations in y equals mx plus b, do I want to use substitution, graphing, or elimination? I want to graph this. So I want you to plug y1 into your calculator in y1, and I want you to plug y2 in your calculator for y2, and I want you to notice where they end up intersecting. Your graph is going to look something like this, where you have two different lines. You have one going with expenses and the other going with income. As you can see, if I publish just a single newspaper, I'm already spending $600. Where I spend 200 newspapers, I'm spending about $800 right here. And it's I'm only bringing in about 300. So here, if I publish 200 newspapers, I'm losing about $500. That's a lot. Okay, now ultimately down here, I'm only in the difference of a couple hundred. Down here, I'm finally going to break even. It means everything I publish after 1,000 newspapers is profit, but I have to sell 1,000 to get my money back. So you're going to end up finding this point at 1,000 and 1,500. If you plug these into your graph, you're going to get something that looks like this as an ordered pair when you go to calculate intersection. So this is telling me that at 1,000 newspapers, I make $1,500. And that is the point at which I start making profit. I have to sell 1,001 to actually earn a profit. Okay, I'm going to give you a similar one that I want you to graph. And all right, you have another equation that just like the one we just did. I need you to write your equations. You want to write them in y equals mx plus b form. And I want you to have your system written. You may graph it and then tell me how many copies must be sold to break even.